Hello everyone. So in this video we will be solving a new lead code problem which is find shortest safe route in a matrix. So before going forward in this video, please make sure that you have liked and subscribed to this channel, and also it's my advice to all of you that please read the problem carefully and try to build up the intuition. Then try to do the code. And if you stuck at any point, then see this video. It will be helpful for you. So let's see the problem statement. Problem is saying that we have given a matrix M mat, which is with R row 1 C columns where some cells of the landmines marked as 0. So 0 is marking as a landmine and others are safe to traverse. Your task is to find the shortest safe path from any cell in the left column of the any cell. Left column of the any cell to the right most column of the matrix. You cannot move diagonally. Okay, so this is the condition. We cannot move diagonally, and you must avoid the both of the landmines and their adjacent cells. Like if my landmine is here, as you can see here, 0 is showing the landmine. So if my landmine is here, I can't go up तो मैं जा ही नहीं सकता, ठीक है. I can't go left, I can't go right, and I can't go bottom up. So this is the problem. So we have to, we are starting from the column 1. We can start from the any row of the column 1. This is like we can start from the any row of the column 1, and we have to reach at the rightmost row column, like here, as you can see. So you cannot move diagonally, and we have to avoid the landmines and their adjacent cells. Okay, so this is the problem. So let's see the intuition for this problem. So the problem is saying that if we have a landmine, like if I have a cell that contains a landmine 0 is showing the landmine, so I can't go the adjacent cells of the landmine, like I can't go left, right, up and down of that particular landmine. So we have to find the unsafe, means safe reason, safe route for this, minimum safe route for this. We can start from the any row from the 0th column, and we can go to the right. We have to go to the rightmost column of that, but any row. Okay, so the approach part would be like we can start from here. If this is my matrix like 1 1 1 1, and you can see this matrix, and if we are starting from this 1, because 1 is the safe region, so we can start from here, and we will go left. Left is nothing. We will go up. Up is nothing. We can go right, or we can go down. So we are going right side. So this is my, for now I am here. So now I have four choices. I can go up. I can't. I can go left, but you can see this is already visited. So this cell is already visited. So we have to keep track of that particular cell. Like if it is visited, then I can't go here. If it is visited, so I can't go here. So that's why we will create a visited array that will show us like if it is this cell is visited or not. If it is already visited, I can't go. So I can go down or right. If we go right, then we I have four choices, like I can go downside, upside, I can't go left, I can go right. If we go right, I can't go up. You can see here, क्योंकि ऊपर तो है ही नहीं कुछ भी, ठीक है. I can go right side. If we go right side, then this is the unsafe reason, because अगर मैं right side में जाता हूँ, ठीक है, उसके जस्ट नीचे क्या हुआ है, लैंडमाइन पड़ी है, ठीक है. सो मैंने पहले भी कहा था कि if there is a landmine, I can't go up, down, left and right, because that is the unsafe reason. So I can't go here because that is the unsafe reason. So I will go here, and I'll go downside. Now I'll check like this is a safe reason or not. Because it is not a safe reason, because adjacent node क्या है इसकी, adjacent cell क्या है, adjacent cell एक landmine है, ठीक है, तो मैं नीचे भी नहीं जा सकता. So we have to return int max. Because why we are returning int max? Because that the reason is we have to find the minimum number of routes. So if we return int max, then ultimately we are returning a minimum number of routes. So minimum of int max comma that particular answer will give me the answer. So I can return int max here. So now second part will be like if we are starting from here, and we can go right side, then we can go down. Now I'll check like this is a safe region or not. This is a safe region. So I have two choices, like three choices, because I can go left, right and down. If we go right, if we go down, then if we go right and then down, then if I am here, like here, if we go right, then that is the unsafe region because उसके ऊपर क्या पड़ा है, लैंडमाइन पड़ा है, तो that is the unsafe region. If we go down, then that is a safe region, and then finally I can go right. So this can be a possible path for this. This can be a possible path. So number of routes like 1, 2, 3, 4, 5, 6. So 6 steps we are taking from reaching out to the ultimate goal, like leftmost rightmost column. So we are taking 6 steps. So now there can be many ways, like हम इस नोड पे हैं तो नीचे भी जा सकते हैं और भी जा सकते हैं. तो अल्टीमेटली आंसर तो इसका 6 है, ठीक है. If we are starting from here, as you can see, if we are starting from here, then if we go here, now I have choices like I can go right. If we go right, then that is the not a possible path. So if we go up, that is not also a possible path. If we go down, now we have three choices like we can go right, left, and down. If we go right, then that is the same as this path. So that is giving me six answer. Okay. If we go left, then I can go here. Now I have to go down because that is only a single way. So that's why if we go down, then there is a danger reason because here is a landmine. So I can't go here. So 6 will be our final answer. So let's tackle the problem. Yeah. So for this, what I will do, I'll create a priority queue that will show us the, like, first pointer of that priority queue will show how many steps we are taking, and second is a second pointer, like second will be a pair of integer comma integer type that will show up from I am here, like 0 comma which index is there, like इस सेल का कौन सा इंडेक्स है, ठीक है. So that will show which index I am here. Like, let's see the code for this. So code is very simple. We are initializing, like, in n is showing the rows, number of rows, and n is showing my number of columns. We are creating a vector of vector type that will show, that is showing the visited array, if this is visited or not. So initially it is marked as 0. It means false, we can say. And we are also creating a distance vector that will show us like what is the distance till now. And we are initializing a minimum distance that is a integer type. And now I am creating a priority queue of pair of integer comma pair of int comma int type. That is a priority queue of max heap. Like we can say max heap that will give me a maximum number. So now I am traversing the matrix. I am using the two loops to traverse this matrix, and now I am checking like if matrix of I of j equals to 0, it means that is a landmine. So what I can do is I will mark it as visited, like visited of I of j is equal to, but I will mark it as visited. And now I will check like if I minus 1 is greater than equal to 0. If this condition is possible, I minus 1 is greater than equal to 0, it means I can go. I'm like it is I minus 1 is greater than equal to 0 is showing the left side of that particular row. This is the I is showing the row and j is showing the column. So I minus 1 is greater than equal to 0 is showing like visited of I minus 1 comma j equals to 1. Like j minus 1 is greater than equal to 0, then also we'll mark it as visited. So we have four ways to mark it as visited. So we'll do this. Now this loop will come. We are traversing the whole n numbers, like we are traversing n is showing the number of rows. So we are traversing the number of rows, and now I'll check if this is not visited. 0 is showing the column. I am at the first column, and now I am checking all the rows. And now I'll check like if it is not visited, if that particular number is not visited, I'll push that number into the priority queue. This one is showing the number of steps. This is the first number of steps. If I am starting from here, like if I am starting from here, so this can be a one possible path. So this is the number of steps, and I comma 0 is showing like I am at the ith row and 0th column, because I am starting from the first column. First column means index is 0. So ith row and 0th column. and distance of I comma 0 equals to 0. This is the my second. Now I am creating a two arrays, we can say dr and dc, that is showing like -1 0 1 0, because if we are traversing the rows, we can either go to the up or down. If we are changing the rows, either we can go up and down. I can't go left and right. If we go left and right, that will change our columns. So that's why we'll go up and right. So that -1 is showing the up, and 1 is showing the down. It means if we are starting from 0th index, -1 is showing the up and 0 is showing 1 is showing the down. So as same as DC is showing right and left. 1 is showing the right, and -1 is showing the left. Now I am traversing the priority queue here, and priority number of rows is like PQ dot top of second dot first. As you can see here, second priority queue of pair of integer comma pair of integer comma integer size. This pair is showing, this integer is showing the number of steps, this is integer showing row, and this is integer showing the columns. So if we are finding out the rows here, so rows will be like pq dot top of second comma first. Second dot first will give me a number of rows. So pq dot top dot second dot first will give me a row, as same as pq dot top dot second will give me a column. And number of steps if like pq dot top dot first, because the first that pq dot top dot first is showing the number of steps. Now I'll pop out that it is like a same of as like a DFS technique, because I'm initializing all the priority key, and now I'm popping out from the top element of the priority queue. Now I'll traverse all four directions, like 4 into I equals to 0 to I less than 4. All four directions I will traverse. I'll create a two variables like int new row and new column. New row will be r plus direct row, means direction of the rows of I, and direction of the columns DC of I. Now I'll check these conditions. If new row is greater than equals to 0, new row is less than n. These conditions are showing like valid condition. Like if the cell is in the matrix, if that particular number is in the matrix and that is not visited also, not of visitor of new row comma new column. So if this condition meets, then I will do, I'll check this distance. If distance of new row comma new column is greater than 1 plus step, then I will change then distance of new row comma new column equals to 1 plus steps, and I'll push that into my priority queue. And this loop is showing with a minimum number of distance. That will give me a minimum distance equals to minimum distance of this comma this. That will give me a minimum number of steps. And finally I will check like if minimum distance is not equals to int max. In that case I will return int max, like return the minimum distance, sorry. So if minimum distance is not equals to int max, because if, as you can see here we are returning the int max. So that's why we are changing this condition, like if that minimum distance is not equal to int max, in that case I will return int max in minimum distance, sorry. And else condition we will return -1. If it is equals to int max, in that condition we will return -1. So let's run this code and see if this will work or not. So as you can see here, the test case is running perfect. Let's submit. Yeah, all test cases have passed. So that is the code. Simply what we are doing is we are using a data structure priority queue that is showing the indexes and number of steps, and we are checking like if there is a 0, then what we'll do, I can't go up, left, right, and down. If there is 1, that is a safe path, I can go from that, and I'll find all the conditions, like all the ways to go from leftmost column to rightmost column, and I'll find the minimum number of steps to reach out the rightmost column. So that was the simple approach for this. So if you find this helpful, then please like, share, and subscribe.